This video is for anyone looking to recalibrate their part probe. So this is a HURCO CNC machine with a renishaw part probe. Maybe you've knocked the probe, maybe you've replaced the stylus, but in this video I'm going to just run through how to get it set up and correctly calibrated. This video is not for anyone that's wired in the probe and they're starting completely from scratch. This is a probe that's already been wired up and it's ready to go. It's just something where you want it recalibrated, or maybe you've replaced the stylus. Also, this isn't a video on how to reset your Z reference in the machine, so if you've lost your Z reference figure, you need to go and watch my other video on how to set that up first before you go and set up and calibrate any tools or part probes. The first thing you want to go ahead and do is call up your part probe and get that into the spindle. Next, what you're going to want to do is put a clock on the probe, because we'll need to clock this probe in. Now, to clock this stylus in, there's 4 screws around the exterior diameter of the head of the probe. You loosen all of those screws, if I remember correctly, and then as you screw in one, you'll need to loosen the other, and it will kind of push the probe, push the stylus left or right or forwards or backwards. To be honest, is a bit of a faff, and it will take you 5 minutes to get the hang of it. But you want to clock this in absolutely as best you can, preferably so that when you spin that probe and the DTI is reading it, it just reads 0 all the way around. That would be the ideal scenario. The other thing to make sure of is basically when you're clocking this probe, I put my DTI on the center of that sphere, so on the center of the ruby. So put your DTI on there first, wind it incrementally up and down in the Z to find the high point, and then also do the same in the X. So wind it left to right until you found the high point. Then just zero it out, and then you can start rotating that probe round and making the adjustments with the screws above. I'm just pointing out the holes in the probe. So those holes there, you'll see there's some tiny little Allen grub screws in there. I believe it's the bottom ones that run all the way around, so not those two top ones, or with those 2 top ones, it's actually the bottom row, so there's 4 of them all the way around. Okay, so once that reads 0 on the DTI and you're happy that stylus isn't all wobbly and wonky and spinning off into the sun, the next thing to do is to go ahead and put a ring gauge on the table. Now, you can either clamp this in a vise or you can clamp this down to the bed. What I like to do is use some really strong small magnets on the bottom just to keep it in place. It's a good idea just to make sure everything is sitting flat as well. Make sure you're not essentially grabbing it on the piss or anything like that. So yeah, you want to get that onto a nice flat surface. There you go there, there's an example in the vise. I usually just magnetize mine to the table. Now once you've done that, you can, by the way, get rid of that tool out of the spindle. You want to go ahead and clock that ring and find the center of that ring. Once you've found the center of that ring gauge, you'll see on the right there under part it says X and Y 0 to the right of my finger. You want to just go and basically zero that out, so you've saved that as 0 0. Then you can go and put your part probe back into the spindle and move it to 0 0, which would be the center of that ring gauge. Once you've got your part probe placed in the center of the ring gauge, you want to go ahead and find the part probe deflection offsets page. And at the top there you'll see ring gauge method, and then you just want to go ahead and fill out all the details. So the diameter of our ring gauge and where our 0 is, etc. So as you can see, I've got a 49.996 diameter ring gauge, and then the actual machine position where that tool currently is, or where the part probe currently is, you want to type those into the X and Y center, or you can just hit store machine position and that will store those current positions into those two little tables. Now this is a step I don't actually think you need to do, but I like to do it because I'm a little bit anal and I like to see what figures are going in there. So I delete all the deflection offset figures in those tables to the right. I make sure they're all 0. But I don't think you actually need to do that. Once you've done that, we're going to close up the doors and we are going to use gauge to get X and Y offsets. So that's going to use all the gauge details that we've put in there, the center of the gauge, and then as usual on these HURCO machines, before it does anything or moves, you always have to push cycle start, so it's never going to do anything scary. Then it will go round, I think it goes round in 36 places, so it'll go around 360 degrees, so that will touch around every 10 degrees, and it might do that twice, I can't remember, but basically what it's doing is it's working out the deflection offsets for the probes. It's basically just working out where it is to where it should be, and it will populate all those figures on the right hand side. So all of those figures that we changed to 0, it's repopulated all those. I personally just like to zero them out because I know when it's done doing what it needs to do, it's repopulated those and there's no silly numbers in there. But I don't think you need to delete those, to be honest. It's just a visual thing for me. I like to see what it's put in there. And once we've got those deflection offsets in there, that is the probe set up for doing diameters now. It's not the Z, we haven't done anything to do with the Z yet, that's just the diameter done. So what I like to do is I just like to run a little circular probing cycle and just to make sure that essentially it doesn't find a different center point for that gauge. You want to just make sure it stays in the same place and also make sure that it reads the correct diameter of the gauge. So my gauge is 49.995 or 96 I think it was, and it's picked that up. So I'm happy with that. I'm happy that that's set, and now we're going to continue on to setting the Z up. Okay, so for setting the Z up of this probe, it's very similar to setting a tool. If you set tools manually using a height gauge of a known height, then setting this probe up is pretty much the same, except because the probe isn't a solid tool, because that probe, the stylus actually moves up and down, there's a little bit of, I guess, fidgeting to do with it. So the first thing is, obviously, you want to make sure your height gauge is in there. If you've got a 50mm slip, then you'll have 50mm in there, and you'll have device 1 selected, if that 50mm is in device 1. Here, for instance, I'm using a 50mm HURCO height setter on top of a 90mm random bit of machined billet, I guess, but it's nice and flat and square, so total is 140mm. So my gauge device or gauge height is 140mm. What we're going to do is we're gonna not touch on the moving pad, because we don't, if it was a solid tool, we would want to probably touch on that moving pad, but because the probe moves, we don't want to touch on that moving pad because we don't know which bit's going to move, whether the pad's going to move or the probe's going to move, and then there's going to be some inconsistencies. So we want to touch on a solid face, which is that shiny face on top, which normally goes flat when you push the pad down of the height gauge. So we're going to touch on there. Now you can just wind down in the Z nice and slowly with the doors open. You see the probe's now gone from flashing red to flashing green. So what you want to do is slowly wind down in the Z and then knock it down into 1% and wind it back up. until it goes red again, and then wind it back down until it goes green. Basically, what you're kind of looking for is to find that little sweet spot as to where the probe triggers. Where it when it changes color, sorry, that means the probe is triggering. So you want to find that sweet spot, and then you just click set length, like any old tool. Except we don't stop quite there, because there's going to be basically a little bit of fidgeting to do with this now. So although the probe is going to be pretty damn close for setting, it's still not going to be quite right. We've got to adjust it slightly now. So although we're really close to getting this finished up now, it's not going to be quite right. So basically, we're just going to run a probing cycle exactly where that probe is right now, and we're going to move down and set it in the Z-axis. Okay, so I'm just probing the Z now, and we should get a small figure. There should be a difference between our actual Z0 that we've set and what the probe thinks it should be set at. And at the moment that's minus 0.301. This is in millimeters, by the way, not inches, so it's not actually that huge of a figure. So what I'm doing here is I'm jumping back to our tool setup page. We've got the probe there, and what I'm going to do is I'm going to change our figure by 0.3. I'm essentially lying to the machine of what the tool length actually is. So I'm going to move that by 0.3. I'm not going to lie, I can't remember which way I moved it. It was either plus or minus, but either way, 0.2, 0.3, you're not going to be too wrong. Then I'm going to reprobe the Z again, and we'll either be at 0 or we're going to be 0.6 out. That's how you know we're out. And here we go. So there's now a difference of 0, which means that probe's correctly set up. If it was out and we went the wrong way, then basically instead of if you added in the first place, then you would take away. But obviously, if you added 0.3 on, you would take away 0.6, for example. Your figures aren't going to be exactly the same as mine. So if you do go the wrong way, it's not the end of the world. I'll be honest, it's been a while since I've set one of these up. I actually recorded this video, so I apologise, but for some reason I've lost the sound. It was a lot better explaining it as I was going. But yeah, for some reason the footage got corrupted, and I had the footage but no sound, so I've had to do a voiceover. So hopefully that'll help you guys out still. So yeah, hopefully it helps someone out. I thought I would also just add in that there's a deflection offset Z down in this page here. Now, the figure we added or subtracted, that 0.3, whatever that difference is, you can actually put that in there, and that will do exactly the same thing as opposed to changing the length of the probe in the tool setup. I just prefer to change the length of the probe in the tool setup and keep that as 0. But it's a personal preference, to be honest. And this is my setup page for the probe as well. All the details in there, like the stylus diameter, that sort of thing. So if you've got the same probe and stylus, then you can just copy those as well if you don't have those. Okay, so that's the end of the HURCO part probe setup video. Sorry if it seems a bit quick and cobbled together. That's basically because it was. It's just some old footage I had laying around, but I thought I'd still release the video anyway because it's probably going to help someone out there. So yeah, I wish you all the best. Hopefully it works for you, and if you like the video or it's helped you out, just leave a comment or a like, and that'd be much appreciated.